Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad. So I would like to present my part, which is the introduction for this project. So this is my group members: Liu Ayin, Liu Aipo, Nuratika binti Muhammad, Nur Hazwani, and Nabil Wafiq Aiman. So the introduction for this project is, in this project, stadium will be built at Pasir Kudan, Johor. So the process of constructing the stadium involves a few considerations at the preliminary stages until the final process. This project will entail several aspects of structural design. For this stadium, truss is a component of structural elements involved in the structural system. Trusses are often used in both buildings and bridges as they are incredibly strong. So to proceed with the design, we need to follow the design of procedure. So we will start with design of beam, followed by design of column, and proceed to design of connection, and last one we will proceed to design of truss. So at the end of the design, we will check whether the design is follow the specification that has been stated. So this is my part of calculation in this project. So the first one is design of critical tension members, and the second one is design of compression members. Okay, thank you. So this is the stadium for this project. The top one is the top view, and the bottom one is side view for the stadium that we will design.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nabil Wafiq Aiman bin Hazar Hisham. My metric card is TF190092. So, I'm going to talk about the determination of the internal force. Okay, from this chapter, we are going to do the software analysis, which a truss construction is made up of a number of joints that are linked by binary member with two opposing forces on them. Depending on its position in the structure, each truss component may carry either compressive or tensile force. The critical member with the greatest value occurred in the top of part of the trusses with 240.85 kN or 241 kN. This is with the value we get from the step pro. Okay, here is the critical member in the step pro of analysis, and the value that we got obtained from the step pro, which is the tension and compression critical members. And here is the comparison between step pro analysis and the manual calculation, which from the step pro analysis we get 240.85 kN, which when we do a manual calculation we get 241.1 kN. It can be shown that the comparison of critical member using step pro and manual calculation is almost similar. This is proven that both of the value is acceptable to be used as the critical member. The critical member of both analysis is occurred as compression member, which is on the top part of the trusses. So with that, thank you.
Hello everyone, I am Aipo, will present the connection. The joint in the connection serves as a safety in terms of transferring force from one structural member to another or to the support. The arrangement of the joint depends on the type of the action, such as the force and the moment, and the type of member, like the compression member or tension member. The principle of load transmission of a bolt connection states that the load is transferred from the one plate to another. The transverse shear force is transmitted from the load that is transmitted into the in and out of the bolt by bearing on the connection plate. The application of the different type of the bolt is responsible for the prevention of the failure of the structure, such as tear out or bolt shear. The welding design will save the cost of the fabrication of the structure. This slide shows the connection design procedure from start until the end of the design. Hello, I am Liu Ayin. I will be presenting the conclusion and the recommendation of this project. Alright, let us start with the conclusion. By using the architecture plan as a guide, the determination of the loading on the roof truss is defined by the material properties. The rooftop material is categorized as the permanent loading. For the maintenance and repair, MSEN 1991-11-2010 from the table National Annex 7 is used for the variable load on the roof, while the Clause 2.4.2 of MS 1553/2002 is highlighted in regard to the wing load on the roof. This is as a result of the stadium is being subjected to the wing load. Overall, the stadium steel truss design was successful in achieving both safety and cost effective, as we choose the steel side and ball grade that precisely in order to withstand the weight because of the safety and economic reason. Next, we'll move to the recommendation. The first one is that the steel side selection should be taken into account. Select the steel sides that are both affordable and able to endure any stress applied to them. The second one is that the size of the structure, cost and safety should all be taken into account while choosing the type of the truss. The steel truss are typically utilized because they have high strength and may be more cost effective than the beam for long span.